standing for term number. Because in all these sequences, there's no in-between term. It's the first term, the second term, third term, fourth term, fifth term, and so on. We don't talk about the 4.5 term. So that's why we use nth term and not x and y. X and y suggests a continuous relationship between the two, so there would be terms in between. We don't use that, so we use an nth to kind of distinguish that. Okay? So that's the nth term, and then we've got a cubic one, the nth term for a cubic one, which I think we wrote yesterday, but it would follow the same pattern. Cubed bn squared plus cn plus d. Okay. Now yesterday, we came to some conclusions, I don't know if you remember them, about differences. So a linear equation is something like 3, 6, 9, 12. And we look at the difference between terms. Remember, this is the first term, second term, third, fourth. The difference between terms here is just add 3. We notice we add 3. If you get a constant first difference, that's the first difference, it is which type of sequence? Linear. Okay. So a linear sequence has a constant first difference. So this is a first difference. A quadratic sequence, then, we looked at yesterday, was one that would have a constant second difference. So we saw that was, a lot of times it was plus 2 yesterday. So a constant second difference. We'll do an example in a second. That's second difference. And we touched upon this, but didn't really go into detail, but the cubic then would have a constant third difference. Okay. All right, and we started to look at the quadratic sequence in general. If I have a quadratic sequence like this, what's the first term of that sequence? I'm just going to look at quadratic again. The first term, so when n is 1, what is that first term? It was, if n is 1, in general it is a plus b plus c. When n is 2, it was 4a plus 2b plus c. Now we're replacing the n with 1 and 2 here in the quadratic. When n was 3, 9a plus 3b plus c. And the n is 4, we had 16a plus 4b plus c. So this is how all quadratic sequences work. This fits all quadratic sequences. I looked at the difference between each one. Move that lines. Difference between each one. How do I get from here to here? What do I need to add to a? I need to add 3a, and I need to add a single b. What do I need to get from here to here? I need to add 5 a's and a single b. C is just there all along. And this one I need to add 7 a's from 9a to 16 and a single b. That's the first difference. To get from here to here then, I'm looking, so this is the first difference I'm looking at here. This is the first term, this one. This is the difference. From here to here, I just add 2a, don't I? Here to here, I just add 2a, because the b is already there. So that's a constant second difference. So constant second difference. All right. How did this help us find what a sequence would be? Now, yesterday we had an example. Maybe I'll just use the same. So if I look at a sequence, 11, 21, 33, this is the one we used yesterday, 47, 63. I'm not sure what type of sequence this is yet. Well, we know it's a quadratic because we did it yesterday. What's the process we go through? We look at the first difference, plus 10 here, plus 12, plus 14, plus 16. Okay, not a constant yet, but if the second difference, plus 2, plus 2, plus 2, is constant. Yeah.
Would we be asked to identify if it's quadratic?
Yes. Most common question is just what is the nth term for this sequence. So you get just a bunch of numbers, and we look at this, we'll do some of these later, and you don't know what type of sequence it is, so you just got to explore the differences. If it works with the first difference, then it's linear. If it works with the second difference, then it's quadratic, and if it goes third difference, then it's cubic, and there's one other type which we'll do on Thursday.
Isn't it like a sequence where you multiply?
Yeah, that's the type we'll do. Geometric, yeah.
Yeah.
Okay. So we have, we know the second difference is 2, we know the first difference is 10, we know the first term is 11. And we use these three things we just created. 2a, 3a plus b, a plus b plus c, and these three numbers to form the sequence. We're trying to fill in this formula. Now, this is directly related to this. It's the same for all quadratic sequence. This 2 is 2a. So 2a equals 2. These two have to be the same. So a must be 1. Yes?
What would happen if they're not the same? So if imagine 7 plus 4.
And then a would be 2.
A would be 2, right?
Yes. Yeah.
So it's still work.
Yeah. And if it's just a here, then it would be, or sorry, if it's just 1 here, then it's going to be a half.
Okay.
So you just set up the equation. This equals that. Okay, I get a to be 1, which is great. I can start filling in my formula. I got 1n squared, or just n squared. Now I need to fill in the b. So I know that 3a plus b is the same as 10. 3a plus b equals 10. And I just found out that a was 1. So I know it's 3 plus b is equal to 10, 3 times 1. So b is 7. 7n. And then I want to find out what c is. A plus b plus c is equal to 11. A plus b plus c is equal to 11. But I already know what a and b are. 1 plus 7 plus c is equal to 11. C is 3. We did this yesterday. 3. Perfect. That is how we do a quadratic sequence. These, unfortunately, you might need to know off by heart. Or remember how to create this thing. Most people just learn them off by heart. Alex, you with me? In body. Okay. Right. So now we must do it for a cubic sequence. Yay. Yes, exciting times. Okay. So I'm going to do the same process. Let's just see what happens. We're going to do for n equal to 1, might need more space, n equal to 1. So we've done quadratic, we've done linear. We're getting rid of all these distractions.
Is there going to be like a method for the quadratic one?
That's quadratic. It's the same. Okay. N is equal to 1, so it's going to be a plus b plus c plus d. Is the first term in the sequence. How do I get that? Well, I just put in 1 for n, 1 for n, 1 for n, and 1 cubed is 1, and 1 squared is 1, and so it's just 1 times a, 1 times b, 1 times c. So that's the first term in any cubic sequence. The first term will be a plus b plus c plus d, the coefficients of these added together, because the first term will sub in 1. The second term will sub in 2,
8.
always. So we got 2 cubed, which is 8a, 2 squared, which is 4b, 2n, and 2c plus d. I shouldn't put this big line again, because I know I'm going to split them. Look at differences now. N is equal to 3.
27a.
Yeah, n cubed, 3 cubed, 27a, 3 squared, 9b, 3n, or 3c, and d. Oh, I did it again. N is equal to 4. 4 cubed? No, 64. 64. 4 squared? Thank you. Okay, so we get this far. Maybe we need another term. We'll just figure that out in a second if we do. What's the difference between this and this? There's 7 A's more, 3B, and a C. Difference between these two? 8 up to 27, 19A, not a nice number. 5 B's and a C. And difference between these two? 37 A's.
7B.
Thanks. You're on a roll. See, maybe I'll do one more. What would it be? I'll just put it up here. When n is equal to 5. Just 125A, that's 5 cubed. 5 squared is 25B. 5C plus D. What would be the last difference here? From 64 to 125? 61? 61 A's. Plus, how many B's did we get extra? 9 B's. And may say 1C. Okay, so the first difference, there is no common. We're looking for a common difference. Dima, you good? Yeah, close the device. Thanks. So we look at that's the first difference. Nothing. Second difference. Okay, it should be a little bit easier to do this. From here to here, 7 up to 19, that's a jump of 12A. And from here to here, it's a jump of 2B, and nothing is added to the C. The jump from here to here, 19 to 37, 20, not 20, sorry, 18A plus 2B. And we'll do the last one. The jump from here to here, 37 up to 61, is it 24? 24A plus 2B. Still no constant. We weren't expecting it, but the second difference is not constant. The third difference? 6A. Yeah, no B's. 6A. And it would be 6A again. Constant. It's the same thing. This one's 6A more, and this one's 6A more. 18 up to 24 is 6A more. We found a constant difference. We're now going to use this, and this to do a cubic sequence. Let me get a cubic sequence up on screen. That's not cubic. I hope this is cubic. 4, 16. So I'm not sure. The one I have on screen here is 4, 16, 44, 94. I have a good idea it's not linear anyway. 172, because it's not one difference between them, and 284. Is it cubic? Well, let's just check. So this is what the process you go through if you see a sequence. Just check the differences. What is added to get the next one?
12.
Plus 12. That's 44. Plus 28, thank you. Oh, 50, that's an easy one. 50. Plus. Okay, and then plus 112, yes. Okay, no common difference there, so it's not linear. We kind of knew that anyway. Is it quadratic?
No.
Plus 16 here. Plus
22.
plus
28.
plus
44. Oh, yeah.
34?
35.
Should be 34. Oh, this should be 80. Is it 88? No, 78. Okay, so what's my common difference? 6 more each time. What numbers do I look at to form the sequence? I'm looking to form this formula. A, B, C, D. I use these and these to help me form that. All right, yeah, 6 is equal to 6A. So that's where we start. We start with we go and work our way back up. 6 is equal to 6A. So that's pretty easy. A is 1. Great. So I'll start filling in the general term here. A is 1, so that's just n cubed. A is 1. What's B now? I use 12A plus 2B is equal to 16. A is 1 from here. Subtract that over, I get 2b is equal to 4, b is equal to 2. So I have plus 2n squared. All right, I know a and b. I now use this one. 7a plus 3b plus c is equal to 12. And I know an a and b already. 7 times 1, 3 times 2 plus c is equal to 12. What's that? 7 plus 6 is c minus 1. 7 plus 6 plus c is equal to 12. That's 13. Subtract it across, you get minus 1. So just replace that. So I probably wouldn't write minus 1. I just write minus n. The c is minus 1. Okay, I just need to do the d. And that's a, b, c, d. A plus b plus c plus d is equal to 4. So we got 1, 2, minus 1 plus 1 plus 2 is 3. Take away 1 is 2. So the difference is this d has to be 2, yeah? So d is 2. And that's the cubic formula, which is a long process, especially if you have to do this every time. That's why most people remember. The first one and the last one are kind of easy to remember. Maybe these two you might get a bit confused with. The quadratic was the same. A plus b plus c was the first one, and 2a is the last one. What was the one in the middle? What was the one? So the three formulas for quadratic without looking at your 3a plus b, yeah, is the one for quadratic that you usually have to remember, and these two for cubic. Does it work? Are we sure it works?
Yes, we're sure it works.
You're sure it works?
100%.
100% sure. How could I make sure it works?
By working backwards.
Yeah. So we got, test any number. We got 1, 2, 3, 4, 5, 6 term. First term, second term, third term, fourth term. Let's just test the fourth term and see if we get 94. Why? I can test any of them. I just want to see does the fourth one work. So if I sub in 4 for n, I should get 94 out. I hope so. 4 cubed plus 2 times 4 squared minus 4 plus 2. 4 cubed is 64. 16 times 2 is 32. Take away 4, add 2. 96, take away 4 is 92. Add another 2, we get 94.
The 2 up there.
A plus b plus c plus d was equal to 4.
Yeah.
And I had a, b, c here, so I just have to solve for d. 1 plus 2 minus 1 plus d is 4.
No, for the equation when you read it.
This 2?
Yeah, like
Here.
The 2 in front of the bracket, 4 squared.
Here. 2n squared.
That's just that we got that from.
Oh,
Yes.
yeah, right, okay.
Okay, time for you guys to do some. There's classwork on ManageBack. There's a lot of these type of ones in standard, and then there's some word problems in extended. It's not going to be homework, but I definitely recommend you doing a lot of it to practice. I'm not going to set it as homework. The answers are there, so you can check as you go. Do. It'll probably be Monday. Yeah. Did I put it? I think I put it on ManageBack, no? Have I set it for Monday, Friday? Just want to make sure we get everything done. Yeah, probably Monday. Hi.
So you know how you did these equations on Saturday? I don't understand how you get n to have 3 plus 2n squared minus n plus 2.
Yeah. So this is once you figured out it's cubic, you know that it's going to form this. Okay, so it's about finding A, B, C, D. I use these 4 numbers I created and the 4 formulas that I had here and just solve them all together. So the 4 formulas, as this one is 6a is related to that one, 6a equals that one. And that will help find a. So a was 1, and I put a as 1, but I just left it out. I didn't put in 1. For 2 of them, it was ended up being 1 and minus 1, but I just put it in as just no number. But you can put in 1 if you want. And then the second one, where's my blue? This equals 12a plus 2b. And I solved that. I knew what a was. This one equals 7a plus 3b plus c. And then I knew what a and b were, so solve c. And then this one was a plus b plus c plus d is equal to that. Yeah, work from the bottom to top. Once I know a, I can solve for b. Once I know a and b, I can solve for c. And once I know a, b, c, I can solve. Okay, let's try the ones that are on managed back. And get help if required. No, that's not. Standard is just finding formula. I think it's some of these questions are on it. But standard is just finding the formula. All the formulas are in the answers anyway, so if you want to try it. Yeah. I know, yeah. I'll edit it later. Thanks. Extended is a lot like paper 6.